So in this video, we're going to go over the sine law, and we're just going to prove the formula and then just do a quick example. So the sine law, we can write this out, and it's a over the sine of a equals b over the sine of b, and c over the sine of c. So if we draw this triangle out, let's make it a little bigger. What we have here is angle A, angle B, angle C, and across from this we have side A, side B, and side C. This is a little c, that's a big C. They look the same. Okay, we can also write this the other way around. It could be sine of A over A is the same as sine of B over B, which is sine of C over C. So these are the same. We can just choose which way we want to write it. But now, how do we prove this? And how do we get this formula? So if we have another triangle, we're going to draw another one out. And this is my A, B, B, C, C. I'm just going to do a line straight down from the vertex of this. I kind of missed the top there. But this is a right angle. So this is a right angle. I'm going to call this H. So it's the height of the triangle. So now if I use SOHCAHTOA, so let's say I have the sine of A, and that's the opposite over the hypotenuse. So that just equals now H over C, right? That's the hypotenuse to this triangle. Well, what if I did this side? So let's say I take the sine of C. Well, the sine of C is just opposite H over the hypotenuse of the little triangle. So this is my little triangle. Okay, well, if I solve for H, that says H is equal to C sine A. And this one is equal to H equals A sine C. So if this equals H and this equals H, this and this must equal the same. So I now have C sine A equals A sine C. And if I divide this side by A and this side by C, I have to do the same to the opposite. So this side's now divided by A and this one's divided by C. My C's cancel out and my A's cancel out. So now I have sine A over A equals sine C over C. Now, this is the proof for this formula, and we can do it for any of the sides. Like we could draw a right angle to this side as well. But that's enough to prove it. Now, if we had a small triangle and we just want to say, let's say this is 29, and there is no angle here. Let's say this is 72. And now this I'll put as, I don't know, 17. I want to solve for this. So now I don't know this angle, but I can find it out because the sum of the interior angles of a triangle is 180 degrees. But that's not important. I can just use the sine law and say, well, I can write it this way as well. So x over the sine of 72 is equal to 17 over the sine of 29. So in this, what I do is I solve for x. So I move the sine 72 over. So I have 17 sine 72 over sine 29. And we just put that into our calculator. So I have 17 times sine 72 divided by sine of 29. Okay, and I'm just gonna, okay, good, I'm in degrees, just had to check. So that's 33. So that means x is equal to 33.3. So now we've solved for this unknown, and that's the sine law.